Hey everybody, Vade here, and today I'm going to be going over an important type of question that really everyone should know how to solve. Now, this is coming from Pre-Calculus with Limits by Ron Larson, one of my favorites, and Paul Battaglia. Uh, the reason why I'm going over this type of problem is firstly, it's kind of difficult for students to actually get this area equation. I've had several students give me this type of question, and they always are confused with how to find the area equation. Also, some sort of domain concerns as well. Now, the one thing that I am a little, kind of, not certain about with this problem is that I would actually argue that these, if say these, one of these were the answers, this should technically be a less x is greater than or equal to, less than or equal to, greater than or equal to, less than or equal to, because it doesn't necessarily specify that the rectangle has to actually have an area, that it cannot have an area of 0. Obviously, if it was asking a question like, find the maximum area of the rectangle, obviously the rectangle would have an area greater than 0. But that's why I would maybe argue in this case, especially in the pre-calculus context, where it doesn't ask you to find the maximum area of this. Keep in mind, you will be asked problems like this in a calculus class, but you will have that additional step. Of course, you'll have to find that area equation, so that's why it's very crucial that you understand this now, so you won't get stuck in calculus. Also, domain, because when you're doing stuff like the tests, the candidates test, or any of your first or second derivative tests, you will need your domain. And most likely in this case, it'll be a closed interval. Um, but like again, they make it an open interval. Kind of don't really agree with that. I would say closed interval is a more appropriate, like technical, um, you know, way of showing the domain. But again, it's all like an argument, really. But yeah, this is the type of question that you should really know in pre-calculus, because you will be asked the same exact thing in a calculus class, but just with that additional step, finding the maximum area, and of course without a calculator, graphing calculator, because you could probably do it right now using your calculator, but in calculus you will learn something called derivatives, and with derivatives you can find the maxes or mins depending on the problem. In this case, it would probably be a maximum, without using a calculator. Probably maybe a calculator for the arithmetic part, but other than that, yeah, no graphing technology. Anyway, so in order to do this problem here, um, let's find first the area. Area is a function of x, so it's going to be a equals to something. Okay, let's just make that clear. It's going to be a equals to something, as shown here. Okay, just making that clear. So this is really nice that they gave a picture here. Sometimes they won't give you a picture in this type of problem. But again, I feel like it's doable if you know, just like this is, y equals to the square root of 36 minus x squared. If we do a little bit of math here, this will be, uh, uh, or like if you think about x squared plus y squared equals to 36, right? The radius is 6. But this is of a full circle. But when we do y squared equals to 36 minus x squared, then y would equal to plus or minus the square root of 36 minus x squared, since this is only the positive of the square root, so then it'll be a semicircle. Of course, above the x-axis, it won't be below the x-axis, and that plus or minus illustrates that it would be the full circle. So that's one way to sort of, hopefully understand here that it's a semicircle, if it doesn't say that it's a semicircle. But yeah, anyway, let us actually begin here. Very nice that they gave us the picture. Don't take that for granted. So yes, it's telling you again, this is the semicircle, and some point x comma y, this will be very helpful, x comma y belongs on the semicircle, right? It's a function. So if this is x, right, x is a vertical, this is a, sorry, a horizontal distance. So we can say that from this is 0, 0. Okay, and I want to make this very clear to you guys. This is 0, 0. From 0 to x is x units. Now this is where students get a little bit confused. What about from here? Now this may be visually apparent to you. This will be negative x comma y. But of course distance is positive, so this will also be x units. Let's think about this for a second. If you thought that this, and this is the common misconception, that this entire length here of the rectangle was x and not 2x, I want you to think for a moment about symmetry. Symmetry with respect to the y-axis. Hopefully this is familiar to you if you see something like x comma y and negative x comma y. What does that remind you of? Well, it reminds you of an even function. Remember, to test for an even function, the following condition has to be true. F of negative x equals to f of x. This is literally saying the exact same thing. What other like function will have this sort of x comma y and negative x comma y characteristic? Well, that's your simple y equals x squared parabola, right? Your parabola, if I say that this is y equals x squared, this will have some x comma y here, and then corresponding that will be uh, negative x comma y. So really, symmetry is your best friend. Okay, you think about the symmetry. Okay, think about the symmetry whenever you're trying to find the area equation, especially if you're on the Cartesian plane. Okay, if you're on the Cartesian plane, then this is like, really easy to visualize, right? Symmetry with respect to the y-axis means if x comma y is a point, then negative x comma y must also be a point if the function is symmetrical with respect to the y-axis. Many ways of testing that. You can actually test it with this function here by using this, or you could also just think about it visually because it gave you a picture. You chop it in half. This is the same and this is the same. Okay? So many ways of testing it. So this is the part where students mix it up. This is x and this is x because of symmetry. That's the best way I can really explain it to you. And of course, this vertical distance, right, is just y regardless. This, or let me use a black pen here. This will be y, right, because the y is unchanged. This will always be y. This will be y. So this vertical distance here is y. To find the area of the rectangle, I'm just going to call this the width. Y is the width, and the length as 2x. So area equals length times width. So then that would equal to 2xy. Are we done yet? Well, I wouldn't say so. If we say that area equals to 2xy, we also have the relationship that this same y over here is equal to this same y here. So then it would just be 2x times our y. Well, what does y equal to? Well, y equals to 36 minus x squared. So just times our square root of 36 minus x squared. So times square root of 36 minus x squared. And this is our area equation. 2x square root of 36 minus x squared. Trust me, symmetry is really your best friend when it comes to this type of problem. This is where students get confused, the symmetry. Okay, they think, oh, I need to know complex geometry in order to get this. No, you don't. It's just functions. It's just algebra. At the end of the day, this is, geometry was not really my best subject, right? So when I got to this level a while back, I was like, wait, what? How am I supposed to get this area equation? I don't know. Like, do I have to use some complex geometry? No. Think about symmetry. Think about this symmetrical. This is symmetrical with the y-axis. How can I test for symmetry with respect to the y-axis? AKA testing if the function is even. f of negative x equals to f of x. I could do it algebraically with this function here. Just let f of x equal to y. Or I could just literally cut this in half and see, yes, this is easily symmetrical with respect to the y-axis. I see that these two parts look the same once chopped in half. That's what symmetry is. Okay, so it's that simple, guys. And again, going back to like the calculus sort of context of this problem, then you would, like you see here, this is obviously not your quadratic. This is not your parabola. This is some, weird function here that, you will need to use a calculator to find the extrema if you don't know calculus. So that's why. They may ask you, like, I think I've seen a couple of problems in this book talking about, oh, use graphing technology to find the maximum area or something like that. So, I mean, again, in this problem specifically, it doesn't ask. But again, just putting it out there because if you're doing pre-calculus, I assume you're gonna do calculus. So that's why. Um, so now graphically determine the domain of the function. Okay, this is again something, this is something that kind of confuses students. Again, I'm sorry if I confuse you a little bit more with the closed interval thing. It's just hopefully you should realize here is that if I plug in like something into the area equation, okay, maybe you can already figure out the values that make this area 0. Or negative. That's kind of what we're going to do here. There are algebraic methods as well, but let's not overcomplicate it. That make this area negative. Like, obviously, we can't have a negative area, but we could, I would argue, have an area of 0, this rectangle. Just this mere point could be at the rectangle. I mean, like, it never said that the rectangle does have to exist, especially in the Cartesian plane. It's more of a theoretical scenario. It's not really like you actually have this rectangle represented as a piece of paper sort of thing. I don't know. That's all I'm trying to say here. This will be more important, I would say, down the line when you get into optimization and calculus. Just with you'll have to do tests and all that kind of stuff. Anyway, so let's, there's an algebraic way to do this. Like, we could do it pure, using pure algebra. Like, we can find the domain of just the square root. Then we can find just the domain of this with respect to, will it make the area positive, negative, and of course we have to account for 0 because, again, open intervals here, open intervals here. One thing I can say for sure is that it won't be an all real number scenario. We plug in a negative here. Square roots will always be positive, okay? Square roots will always be positive. Hopefully you know that. This will obviously be a negative area, so all real numbers will definitely not work. Okay, all real numbers, again, all the all real number scenarios will just not work. Okay? So now thinking about this here, again, we could like say 36 minus x squared greater than or equal to 0. This is then a quadratic inequality times 6 plus x, okay, greater than or equal to 0. We can do our little test here. This is negative, this should be a closed circle here. But technically, okay, we can make this, it's an open interval here, so because of the answer choices, really don't support that entirely. This should be negative 6. This should be 6. We have the 6 minus x here, the 6 plus x. This is negative infinity. This is positive infinity. Again, this is just the quadratic inequality process. I'm going to put this more to the left here. 6 minus x, 6 plus x. Okay, so this is negative infinity. Anything negative of negative, this will be a positive, negative, negative, and then this could be 0, positive, 0, positive. This is negative, and this is positive. So then negative times positive times negative is negative, positive times positive is positive, negative times positive is negative, so it'll be like a negative, positive, negative. So the area will be greater than 0. So x is greater than negative 6 and less than 6. And then, of course, going down to here, again, making it easier on ourselves, we can also see here x cannot be x cannot be negative, obviously. So x cannot be negative 6, right? X cannot be negative 1. X cannot be 0 because open intervals, unfortunately. So kind of using common logic here, x must be in between 0 and 6. And we can see that here. Of course, if we plug in 6, area will be 0. 36 minus 6 squared, 36 minus 36, 0. Anything times 0 is 0. Area would be 0. Technically should be allowed, but it's not. I know I keep saying that, but it's the truth. Plug in 0.01 will still be positive area. Plug in 5.9, positive area. So this would be the correct answer right here. Sorry this video took long. It took so long. I'm just trying to like help you guys understand. You know, again, finding the domain part, you didn't really even need to do all this. Okay, I'm just trying to make it most, you know, logically very clear what I'm doing. You can obviously guess and check sort of thing, like can't be negative. I know square roots are always positive, so this factor right here always will be a plus. This can be a 0 or a minus, and just logically deduce, oh, then if I make this 6 or negative 6, this will be 0. Yeah, like you didn't have to do this, but I'm trying to make it very clear that there is an algebraic way to do this as well. But of course, for the sake of time, you could definitely guess and check and probably get the right answer, especially in a multiple choice scenario. But yeah, please study these types of problems. These are very, very important as you move on down the line, and especially into calculus. Let's move on to the next one here in the next video.